Hello, everybody. Today I'm going to be talking about a recent federal highway initiative looking at industry practices and suggestions for adjusting asphalt mixtures to meet balanced mix design specifications. My name is Thomas Bennett. I work at Rutgers University for the Center of Advanced Infrastructure and Transportation, and I'll be providing this presentation today. To help provide a little bit less bandwidth on this presentation, I'm going to keep my camera off for the presentation, then I'll come back towards the end. As I mentioned, this is a federal highway initiative, and so we have some obligatory federal highway language here that this material is disseminated under the sponsorship of the U.S. Department of Transportation. You can read the rest of the information along with it at a later time. The research project and paper that was developed out of this is a final tech brief right now. It can be downloaded at the link below. This is also available on the University of Nevada, Reno website. And if you have any issues trying to find it, if you just Google UNR BMD Federal Highway, you'd be certain to find this, and along with a lot of other information that they've been compiling under this federal highway initiative. The general approach of this particular study was that we selected 7 industry personnel that had a vast experience in balanced mix design. They were regionally diverse, and also their organization background was diverse. So we wanted consultants, we wanted testing laboratories, and we wanted contractors and suppliers. This way we can get a good overview of the different industry perspectives of balanced mix design. Each interview took place for approximately 2 days. Questions were provided ahead of time. This way we could go ahead and have a well-prepared interviewee that we can talk to and get as many details as possible. We conducted a post-interview to make sure that all the responses were recorded correctly, consolidated all the findings, and we developed the best practices document that I mentioned earlier. Now, the general overview of this presentation is we're going to talk about the interviewees and their experience, their BMD approach considerations and mechanical testing, their perspective on adjustments to asphalt mixture components to meet BMD criteria, some of the suggestions that they provided to help improve the BMD implementation going forward, and then some general conclusions and final remarks. So the interviewees and their experiences. So as I mentioned before, we had 7 different interviewees, and you can see the cross section on the United States map on the right. A large group from the middle to eastern part of the United States, but we also had some from California representing the West Coast. In particular, our 7 interviewees were Ray Bonnequist, who is currently the Chief Operating Officer at Advanced Asphalt Technologies. Obviously, people who are involved with asphalt mixture testing know Ray quite well, and he's been at AAT for 24 years now, prior to that with Federal Highway. Andrew Hands, he's a VP at Technology and Research at Matthey. He had worked at University of Wisconsin for a number of years as a postdoc, and has vast experience in mixture production and performance testing, as well as binder characterization. Brian Prowl, former NCAT Assistant Director, also worked at the VTRC for quite a while. Currently is a Principal Engineer at Advanced Materials Services for the past 15 years. Michael Cleames and Marty McNamara, working at Granite Construction in California, a combined experience of approximately 30 years working with asphalt mixtures and mixture testing. Phil Blankenship, owner and CEO of Blankenship Asphalt Technology and Training. He's had that company for the past 4 years, but most people would recognize his name from Asphalt Institute, Kentucky Transportation Cabinet, and Koch Industries prior. Greg Rose, quality manager at Bar Stone in New York State, has been a mix producer for approximately 30 years now. And the last one, Pat, but not least, Pat Coaster is the Vice President Production of Howell Paving. 17 years at the current position, but 28 overall in the organization. Prior to that, he was with the Illinois Department of Transportation. So quite a wide range of people that we had involved with the interview process. Again, just a quick background of what balanced mixed design approaches are. We have approaches A through D. A being the tightest with respect to volumetric design, but probably the easiest to implement. D being much more flexible from the design perspective, but creates a number of things that need to be considered as the complexity of that approach from an implementation standpoint gets greater. Approach B has volumetric design with some performance optimization. Approach C allows for some performance modified volumetric design when you're allowed to change the volumetrics slightly in order to meet the performance criteria. Not to spend too much time on this, but if needed, you can go to the AASHTO PP 105, the standard practice for balanced mixed design, as well as the Federal Highway Tech Brief balanced mixed design, the 8 tasks for implementation. Both of these documents define these approaches quite well. If you look at the table here, you'll see the organizational and interviewee experiences with the different BMD approaches. Majority of the interviewees were utilizing approach A for a majority of their work. You can see in some instances there was an approach B and C taken with advanced material services, and even an approach D by Granite Construction in California on a recent project as well. So a majority of the use recently have been on the approach A, with some small volumetric changes with B and C, with only one project that we'll be able to utilize and showing with approach D. Next section, we'll talk about the different BMD approaches and the mechanical testing that is commonly used in those approaches. In the table, you'll see that there's a number of different mechanical performance tests that were identified for both a mixed design approach, but then also for production and or QA. And what you'll see there is that a lot of the work is being done in these IDT base type tests. You can see advanced asphalt technologies using both the high temperature and the ideal CT. Advanced material services using the ideal CT as well. And so is Blankenship, Barstone, utilizing those IDT tests. And especially if you look at the production in QA, you can see that those sort of tests are being pushed more, most likely because they're easier to implement and much quicker to use. There's no gluing, cutting, external fixturing that really need to be done regarding those tests. However, a few are still using the Hamburg wheel tracking. Some are using the SCB, but those have a tendency to be a little bit more state specific as to those criteria. The other thing that we asked our interviewees and we wanted to see is what are some critical volumetric criteria that you believe we really shouldn't leave right now. We really shouldn't take out of our specifications because they do provide a large benefit in how to redesign or change during production to make sure that the materials are meeting performance. You can see here air voids being a very critical one, how the material is compacting. Binder content by volume or effective binder with your VMA and VFA all seem to have been very consistent markers from a volumetric perspective that our interviewees identified as, even though they are using mechanical tests, these are some volumetric properties that they don't want to take away right now out of the specifications because they do believe that they provide extremely good guidance on mixture performance. The interviewees questions regarding volumetric properties versus mechanical testing and some of the key differences that they're going to see in the future as we move away from volumetric properties to mechanical testing. And one of the biggest ones that there was a consensus on was that there appears to be a lack of understanding regarding the impact of mixture component adjustments to final mix performance. Right now, we have quite a bit of experience in the field with respect to how I can make a plant adjustment to meet VMA, or what do I need to do during plant production to close up my VMA, or increase air voids, decrease air voids. And we have a very good understanding of how to change mixture components to achieve our volumetric properties. But right now, there's a lack of understanding and even education regarding what are some changes that I need to make to meet my rutting test or my cracking test. And that's something that needs to be thought about on the implementation side, a change of education. Also, state DOTs need to understand that some biometric criteria may need to be eliminated or relaxed to achieve some desired performance. A number of our interviewees spoke about reducing air voids to allow greater asphalt contents, allowing dust to binder content to possibly be a little bit higher for wrap mixes that are still meeting a fatigue cracking test. And a lot of that is based off of the experience and how well the agency feels regarding the test method itself and the confidence in the criteria. So things to understand as moving forward is that biometric criteria does still play a role in how we make adjustments. They're not going to tell us everything about cracking and rutting, and that some of these volumetric criteria may need to be relaxed in order to make sure that we can make a good performing mix. We asked our interviewees, what's the primary reason for you in selecting the balanced mix design approach to mix design? And not in any particular order, but these seem to have been the more common answers. First, that the interviewees that we did ask thought that the tests were very practical and simple, that BMD is not a process that is that complicated. We're testing the material, we're making sure that they meet a minimum rutting and a minimum cracking standard that the agency feels comfortable with and reflects field performance, and that these things are not necessarily as complicated as made out to believe. If they're going to meet performance, then the interviewees would think that this is a higher quality asphalt material, that this material should perform better in the field. If it performs better in the laboratory, then that should be reflected in the field performance. It's easier to obtain high quality standardized test equipment now. That was another response from our interviewees, and that is the case. You can see that there's a number of different equipment companies that are producing some of this testing equipment at a much cheaper rate than what was in the past for some of this equipment. And a lot of the tests have been even more simplified that could be used on just general equipment in the laboratory now. They do believe that if moving to a balanced mix design approach, there'll be some better coordination and communication with state DOTs. They think that that will improve as there's a learning curve that both the agency and industry are going to have to work around. They also feel that the results in a QA program are going to be better because now there's a performance criteria attached. And they also think that moving to a balanced mix design approach is going to help with specific distresses. An approach A, for example, in New Jersey, we found that it was used quite successfully to help mitigate reflective cracking. We could utilize it in developing better mixes for perpetual pavement and even design specialty mixes for bridge deck waterproof overlay. As I mentioned earlier about the balanced mix design criteria for an agency, you can see here is New York State Department of Transportation as a quick example. You can see that they have both a rutting test and the high temperature IDT, and they're currently looking at two cracking tests, the ideal CT and the SCB flexibility index, as test methods that they've included in their balanced mix design approach. They've done a very good job at describing the test method, describing the specimen size, the heights depending on nominal aggregate size to make sure that there's not going to be an issue of compaction, and also the different levels of conditioning they want their mixes to be conditioned for, whether it's a lab mix design or plant produced, and also the test temperature for these tests and how much conditioning. It's important that a state agency describes this very well and clear so that industry can follow and results between the two groups can be repeatable. Here's two more examples of criteria and specifications that are being utilized for BMD in the states of Kentucky and California. You can see here that they have different aging protocols depending on the test method and how the materials are going to be produced as well, very similar to New York State, but they are using different tests. You can see in Kentucky they're looking to utilize the Hamburg, and depending on whether it's a mixed design or plant produced, they have different conditioning levels. They are looking at using the ideal CT for cracking, and again, very similar difference in aging protocols, and also leveraging the Hamburg for moisture damage as well. The work being done out in California and provided to us from the boys over at Granite, you can see here that they've got quite different methods with respect to how to sample the material. Plant drops in metal cans, storing it for 24 hours, and then reheating it for 2.5 and compacting. Very specific methodologies that they feel works well out in Caltrans. The same exact thing for the flexibility index and the Hamburg. So important to understand when working with a state agency that their criteria may be different, but not just the criteria, but also the way that we handle the materials. And that's all going to be reflected in the final outcomes and performance of these different performance tests. One of the issues that our interviewees thought is going to be challenging to implement is the concept of aging or mixture conditioning. This is very easily accomplished during mix design, as the designer usually has time to take this into consideration during their lab schedules. But how do we incorporate any sort of mixture aging or conditioning for our fatigue cracking specimens during a plant production schedule, during QC? This is going to be quite a challenging endeavor that is going to be researched for the next couple of years under a number of state and national projects. You can see here there's some work being done by the Minnesota Department of Transportation. There's going to be an NCHRP project, all with trying to develop a aging framework that can be utilized across the balanced mix design scheme, whether it's mix design, production, or QA, that will help to reflect the aging that occurs in the field to ensure that we have better mixes that perform in cracking modes. We're going to be talking about our individual responses from our interviewees regarding adjustments to asphalt mixture components to satisfy these BMD criteria. The first up is going to be Ray Bonnequist of Advanced Asphalt Technologies. And what Ray recommends is that looking at something like the high temperature IDT is great for rutting. It's fast, it's cheap, and something that most laboratories can invest in. From a volumetric standpoint and how to make some changes during mix design, if you want to improve rutting, look at limiting or reducing your VMA, essentially taking a little asphalt out. Rutting, he's found, decreases as wrap content increases as long as you're not adjusting it for a softer asphalt binder or a recycling agent. And generally, stiffer asphalt binders will help improve rutting resistance. One of the other things that Ray mentioned that could be of help to those is looking at something like a regression model that's been used to calibrate a lot of data to a particular performance test or even field rutting. The resistivity rutting model, which is something that both Ray and Don Christensen from AAT developed, can provide some insights into factors that significantly impact rutting. And one can utilize this very quickly, and I'll show you this in a second. On the cracking side, well, again, because it's balanced mix design, what you do at one end of that seesaw will affect the other. On the cracking side, if we want to improve cracking, we have to increase the effective binder, which is basically opposite of rutting. We have to make sure we pay close attention to the recycled asphalt, not just the content, but also the source. Make sure that we go ahead and have a proper justification relative to a reclaimed binder ratio and the effectiveness of recycling agents. A little recycling agent may be good, but too much can be detrimental to the rutting side. And also, if a low temperature cracking performance test is required, the binder properties usually will be the predominant factor. In this case, if you have a better low temperature binder PG grade, that will give you better low temperature cracking performance. Example, the resistivity rutting model that Ray had mentioned. And again, you can look this up. It was a transportation research record paper by Don Christensen and Ray Bonnequist. And the schematic over on the right is something that we've put together at Rutgers University as not just a teaching tool, but also helps us with selecting mixture components to change the rutting properties of our mixes. And it's fairly simple and easy to use. It was developed through NCHRP projects 925 and 931. And it includes inputs such as the non-recoverable creep compliance of the asphalt binder, the air voids, the VMA, gradation, bulk gravity, and then also some little aging component depending on the time it was placed and the time that you're evaluating it. All of this provides you with the number of million easels to meet a particular rut depth, and that's how it was originally designed. But it could be somewhat calibrated to your performance tests as well, as long as you take that performance test into consideration in the calibration. Again, if you need a little bit more help in trying to find this document, you can look down below. There's a link on the UNR website that provides you with more information on this resistivity rutting model as well. Brian Prowl at Advanced Materials Services. What Brian recommended is that if you wanted to improve your rutting, use a polymer modified binder. Very quick and easy way to do that. Increase your angularity of your sand-sized particles, your aggregates passing the number 4. So having something with a higher fine aggregate angularity or uncompacted voids will help improve your rutting performance. From a cracking performance, Brian recommended trying to add a little bit more binder and increase that VMA. Increase your voids filled to improve the overall cracking performance. That was a key factor that Brian said that he sees in a lot of his designs. He also suggested that state agencies are going to have to try to reduce air voids a little bit, maybe as low as 2%, to allow for a reasonable amount of asphalt binder in that mix. If the state agency is going to have a rutting test and a cracking test, reducing the air voids and allowing more asphalt in can always be checked on the rutting tests. He also says he likes to customize his cracking tests for different needs. He likes to look at the overlay tester for composite pavements. He likes to look at the flexural beam fatigue for flexible pavements. And so he actually looks to look at different performance tests based on the mode of cracking he sees in the field. Phil Blankenship what adjustments he would make to make sure that he meets his performance tests. A couple of the key things that he said for the rutting side were to evaluate the gradation combinations based on the VMA and optimize the job mix formula based on rutting mechanical test outcomes. He would ensure that you lower the natural sand content, increase the angularity as we saw earlier, and also look at the dust particle size. What he's seeing in Kentucky is that the dust type does matter in how the mixtures are performing in a rutting perspective. Cracking, he said the obvious one would be to add more asphalt binder, but he also said that some aggregates may need to be washed that have a high fines content. He found dust to affect the binder to be a contributing factor to some cracking issues. He recommended look at adjusting the binder type. Try using a softer asphalt binder to help reduce the stiffness of the mix. And one of the things that he did say was that in his personal experience, the ideal CT test may not capture all the full benefit of polymer modified binders. And there's something that needs to be considered and taken a look at when running that particular test for modified asphalts. Caltrans, in work with University of California, Davis, put together a nice flow chart on how to adjust asphalt mixtures to meet performance tests. And what a designer would do is start from the top and work their way down and select different things such as where your gradation is, where your dust content is, what your binder grade is. And these flow charts can be very helpful in a new mix designer battle their way through trying to meet a series of performance tests they may not be accustomed to. This is again something that can be downloaded at that reference below. Speaking with Pat Koister or at Howell Paving, what they have found is that to help meet their rutting, they usually need to add some recycled asphalt. It helps to stiffen up the mix. And they found it to be very cost effective that way. They can replace some of the neat asphalt binder with some polymer modified binder. Going from a neat to a polymer helps to increase the high temperature stiffness of the material, as well as using higher percentages of crushed sand. If they want to meet cracking, what Pat has found is that they want to lower the range of the design air voids to help increase the asphalt content. Also, binder source makes a big difference. And understand that even though it may have the same PG grade, different sources may result in different levels of performance. With Andrew Hands at Matthew Construction, what Andrew discovered is that if the result is close to passing the Hamburg criteria, it may not necessarily be rutting, but maybe some of the stripping potential of the material. And that you can make that material pass if you go ahead and utilize an anti-strip. There's that coupling of effects between rutting and stripping potential in that wet Hamburg wheel tracking test. If the result is far from the passing criteria and an anti-strip won't help, what Andrew found is you have to increase the PG grade. Modify the gradation and make that structure reduce the VMA, take some effective binder out, and increase the use of manufactured fines, the angularity and the texture of the aggregates. If the mix is not meeting the cracking criteria, he found that really one adjustment might just be mix dependent, and that one size doesn't fit all, and that some experience is going to be needed when handling different mixes from a particular facility. If it's a stiffness type of a test, use a softer binder or increase your VMA, get more effective asphalt into that material. When utilizing wrap, he thinks that wrap may help to be optimized, the usage of wrap might be optimized through the cracking test, and that the wrap type does matter. And that's something that again goes back to the binder source, that the source matters as well. One of the things he wanted to note is that the test temperature for cracking tests should be adjusted based on the geographical location or the binder grade being used, and that adopting one cracking test from one region of the country to another without changing it to be more regionally specific may result in incorrect correlations between the cracking test and the measured cracking in the field. Comments our interviewees made was that when you're going ahead and making any adjustment, make sure you follow a systematic approach for making these changes and only make one change at a time. Changing something like asphalt content and dust content altogether may result in a change, but you're not really sure as to what caused the resultant change. Also, during production, make sure you produce a sufficient enough mixture so that you can take into account for that change, especially when you're thinking about a drum plant requires 50 to 100 tons of mix just for the plant to settle out. So make sure enough material has been produced that you can actually quantify whether a net change in mixture performance has occurred or not. A number of the interviewees also talked about looking at something like the Bailey method. And that concept helps, that mix design concept was defined to look at the impact of the aggregate properties on the effective asphalt content, the packing of those aggregates, and designing sufficient VMA to make sure that you are going to go ahead and get durability. So something like a Bailey method concept introduced with performance testing may help state agencies and mix designers producing a durable and rut-resistant mix. Interviewees also suggested that somebody who's designing an asphalt mixture needs to consider balancing the use of both volumetric properties and mechanical testing together. Don't focus solely on mechanical testing to solve all of the issues, and that sometimes these issues can be solved by knowledge of what the volumetrics are and knowledge of what change in volumetrics creates a particular change in mixture performance. Also, from a very practical consideration, and if you think about the mix design that was conducted by Veeam back in the early 40s and 50s, was that you try to get as much asphalt into the mix as possible before you have a stability issue. And sometimes you can actually counteract some of these stability issues by using a polymer modified binder or a stiffer asphalt. So they all simplified it and dumbed it down to get as much binder as you can in the mix until you have a stability issue. And if you're not using a polymer modified binder and you still have a stability issue, change to a polymer modified binder. And this should be able to allow you to balance both the rutting and cracking properties of that mix. Suggestions that our interviewees made to help improve BMD going forward. One of the common suggestions that our interviewees made to help improve balanced mix design moving forward was that there needs to be a greater emphasis on the research and training needs of BMD. Really a national coordinated effort to develop some type of a regional or a national training program, similar to what we might have with our current asphalt mixture design programs, is necessary. Federal Highway has put together a number of seminars on this for free to the state agencies. NCAT with NAPA have put together a balanced mix design guide and have created a laboratory training program. The Virginia Education Center for Asphalt Technology is working with Virginia Department of Transportation on putting together a balanced mix design workshop that allows their designers and agency people to get more educated on the concept of balanced mix design. They also suggested that there's going to need to be training programs for the mix designers and the technicians that are running these tests. Almost something similar to what we currently have with the AASHTO resource program, where there's going to necessarily be an assessment, maybe even a proficiency sample program, but something that can be utilized to ensure that we're getting repeatable and accurate results from the testing side. With that thought on accreditation, you can see here that there's a very short list of what tests AASHTO resource actually has accredited right now. Hamburg wheel tracking, which has been on the list for quite a while, the Asphalt pavement analyzer, and the ideal CT have both been added in 2023. But this is only 3 of these performance tests of the list of over 12 to 13 that some people are utilizing across the country. And so there needs to be a greater push and urgency on trying to get an accreditation program to make sure that both the technicians and the equipment are properly trained and calibrated to ensure that we're getting accurate results. Also, we have to consider that if states are going to have multiple tests, that there should be some sort of standardization between these tests. There are some border states that may want to think about using completely different test methods, which would require an asphalt mixture supplier to have to conduct multiple tests to get their mixes approved. You can see some examples below from Matthew Construction, who produces and supplies material for Wisconsin, Iowa, Minnesota, and Illinois, the number of different tests that they have to conduct to satisfy that respective state agency. And this can be very complicated and cumbersome for an asphalt mix supplier. So if there's a way to simplify this, maybe establish some sort of relationship between test methods that would allow for similar criteria, could certainly help asphalt mix suppliers that are supplying to multiple states. Suggestions that our interviewees had regarding making improvements to the balanced mix design system moving forward was that a comment was made regarding that if the balanced mix design adds a mechanical test criteria without really adding additional benefit to the mix designer and supplier, why bother? Can we consider possibly having pay adjustments in the future where if the performance is exceptional and far above the minimum criteria, should that mix supplier and contractor be paid more for that material? Also needs to consider that we must be more flexible in our design and specification process if we're going to try to optimize a design. Looking at possibly relaxing specifications on wrap content, dust to effective binder, gradation tolerances. As long as the mix meets the rutting and the cracking criteria established by the state agency, then some of those specification constraints that are currently applied should be relaxed or even removed in lieu of confidence in the performance tests. The other common suggestion that our interviewees made is that when criteria is selected, the agency needs to consider tying that back to some level of structural design. That obviously we need something that's extremely rut resistant in the surface for high volume traffic, but low volume in the base may not have to have the same level of rutting resistance. And so making sure that we have a tiered system very similar to what we had with our prior superpave material selection criteria, our consensus properties, would be advantageous to the mix designer and the agency to help a system tied back to some level of structural design. You can see an example from the New Jersey Department of Transportation on their high wrap specification where they do require different levels of rutting, whether it's a neat binder on a lower volume road or a polymer modified binder on a higher volume road. And also that criteria is dependent on whether it's in the surface or the intermediate and base, both for rutting and cracking. So tying it back to our structural design is very important to be consistent with our current superpave system. A few closing comments to tie a bow around this presentation. Our interviewees had significant experience in BMD. They still had some questions that they thought need to be identified and answered to ensure that the BMD process was going to be implemented responsibly and correctly for the agency and by industry. Such as, how are we going to handle variability from contractor to state DOT? Validating lab produced versus plant produced. Are we going to need different handling processes, or should we look at different criteria? We want to make sure that we have a practical test, something that can quickly be used, but not sacrifice the accuracy at the same time. Making sure that there's proper training for specimen fabrication and testing to ensure that additional variability isn't being created during that process. Training on the impact of mixture components, similar to what we're trying to do here in this webinar, to ensure that people that are working at the plant on the mix design and production side understand the necessary changes that need to be made in a mix to meet performance criteria. The importance of an accreditation program, such as an AASHTO resource program for performance testing. Encouraging more state agencies to utilize round-robin programs to aid in training and equipment technician checks. And last but not least, where to collect the necessary information for support. There should almost be a clearinghouse website of some sort where people can always turn to look to get this information that they can go ahead and research and utilize for their own work. And consolidating all of our interviewees' responses to our 2 days worth of questions. If we really want to go ahead and make some mixture adjustments to meet our rutting and cracking tests, this is what it comes down to. From a rutting perspective, you're going to have to think about minimizing effective asphalt content, maybe designing your mix at the low end of the VMA specification. You're going to look to try to increase your high temperature binder grade, whether that's utilizing polymer modified asphalts or additional recycled asphalt in the mix, and ensuring that you're getting good angular and textured aggregates in that material to ensure that you're getting adequate shear resistance internally in that mix is going to be critical. To meet the cracking, we want to make sure that we have enough effective binder in there, designed to make sure that we have a good amount of VMA to have that durability. Looking at, from a volumetric perspective, increasing your voids filled with asphalt. Now remember that that's an increase in VMA with a decrease in air voids. That can be handled that way by lowering your air void. Watching the impact of the recycled binder and the source of the recycled binder. And last but not least, binder source can have a significant impact on performance. And quite honestly, when we're looking at these things, when we want to consider all of this together, increasing effective asphalt with the use of a polymer modified binder might be something that could be very quickly implemented and used in a very simplified manner to ensure that we're getting our durability and rutting resistance. I want to thank everybody for listening into this presentation. It was a pleasure working with Federal Highway and the interviewees on this project, and good luck moving forward in your balanced mix design goals.